Okay, hello and welcome back to Honors Topics in Physics. I wanted to start by reviewing what these words, what the symbols for were in the equations. I would draw this on the board, except you know what, I can. Let's try it. So the symbol for displacement is delta x. The symbol for initial velocity, remember, is v1. The symbol for final velocity is v2. The symbol for average acceleration is a, or a with a line over it. We're only going to deal with one a, whereas we've got multiple v's. So a or a with a line over it doesn't really matter because there only will be one a in this class. Initial position, which is x1, which we won't be dealing with much today. Final position is x2. And what's the symbol for average velocity? Keep in mind, we've got three velocities. I guess technically four. It's v with a line over it. So v bar is average velocity. And the change in velocity is delta v. So the change in velocity is delta v. So a little bit of a review. So we're going to get another equation today. So we'll have three equations, and it's very important that you stay with me today, because if you don't, you're just going to get more and more lost. So if you do get lost, try to figure it out with the examples that I give, and get unlost as soon as you can. Okay, so just start out with a little example here. Here we've got a car that starts from rest, and it travels 80 meters, and it does that in 2 seconds. Okay, so the initial velocity, since it started from rest, was 0. The final velocity, since it came to a stop, is 0. And what was the average velocity? Remember how we calculate average velocity? Displacement over time. The average velocity is 40 meters per second. So notice that the car's acceleration wasn't constant, because it sped up and then it slowed down. So it didn't have a constant acceleration. So now let's look at something that does have a constant acceleration. We start from rest and we speed up and we travel our 80 meters, and we do that in 2 seconds. So our initial velocity is 0. Our final velocity was 80. And our average velocity, again, was 80 divided by 2, which is 40 meters per second. Notice that the average velocity is the average of the initial and the final velocities, because our acceleration was constant. So that's kind of the key point here, is that if your acceleration is constant, then your average velocity is just the average of your two velocities. So let's look at one more example. Let's say we're not from rest. So let's say we start at 30 meters per second and speed up to 50 meters per second, and then we travel that same 80 meters in 2 seconds. So our average velocity is 40 meters per second, with 80 divided by 2. And notice again that is the same. That is the average of v1 and v2. Okay, so this is your third equation, which is the average velocity equals the average of the two velocities, v1 plus v2 all over 2. This is a big equation for you. So now we've got three equations that we are using, not counting the speed equation, because that's the same as v bar equals delta x plus t, or delta x over t. So that is this equation. Write this one down. And so these are our three equations. You should have them written down. V bar equals delta x over t. V bar equals v1 plus v2 over 2. And then you can have this form written down, but I really would probably just have this form written down. V2 equals V1 plus AT. So I would write those down in a row and label them 1, 2, and 3. Label them 1, 2, and 3. So take a second and do that on your notes now, is what I would do. Okay, so let's work a couple problems with these. So a car accelerates from rest to 25 meters per second in 10 seconds. What's its average velocity, and how far does it go in this time? Okay, so first off, you want to underline in the problem what you know. So here we know v1 equals 0. Okay. Here we know v2 equals 25 meters per second. Excuse my writing, which is probably worse, a little worse than normal because I'm trying to write with the mouse. And then we got that the time is equal to 10 seconds. Okay, what's the average velocity? So what symbol are we looking for? We're looking for v bar. Okay, so let's go to our next slide. So here are the equations written out, and I've numbered them 1, 2, and 3 just so I can show you which equation I'm using, and plus it's just kind of something to get used to. So if we want to find v bar, we've got two equations. We've got delta x over t, and we've got v1 plus v2 over 2. Okay, and these are our givens. Well, I don't have delta x, so I can't use equation 1. Okay, so that probably means I'm going to move on to equation 2. And I do have v1 and v2. So I'm going to go ahead and plug those into equation number 2. 0 plus 25 over 2 equals 12.5 meters per second. The next part of the question is how far does it travel? So if it's asking that, it's asking for the displacement. Okay, and there's only one equation with the displacement in it, v number 1. V bar equals delta x over t. Now I'm going to use the v bar that I just found up above here and set that equal to delta x over t, which is 10. Okay, and multiply through, and you get 125 meters. Okay, make sure that if you're not getting these equations, that you come by and see me during my office hours, because you will get behind very quickly at this point if you don't follow these. So don't be afraid to come by my office hour. So here, second example, a car accelerates from 15 to 25 meters per second in 10 seconds. How far does it go in this time? So we've got v1 as 15, we've got v2 as 25, and we've got t as 10 seconds. Take the time to go ahead and label what's in the problem. It will help you, especially if you tend to get a little stuck. Take the time to do this. How far does it go in this time? Okay, so we're looking for displacement. That's my question mark. Okay, all right, so let's move on to the problem. So so how we're going to do this is very similar to the previous example. We're going to figure out delta x, which means I need to use equation number 1. Now to use equation 1, I need the time, which I have, and I need to know average velocity, which I don't have. So that means I need to go back and use equation number 2. So equation number 2, v bar equals v1, 15 plus 25 all over 2, okay, equals 20. So that's my average velocity. And now that I've got my average velocity, I can plug that into equation 1 with my time and get 200 meters. Okay? All right. I've got 2 more examples, this and 1 more. So a car accelerates from rest at a rate of 4 meters per second squared for 12 seconds. Okay, how far does it travel? Let's underline and see what we're given. v1 equals 0. Okay. 4 meters per second squared. The meters per second squared tells me that that's my acceleration. Okay. And the 12 seconds, that tells me that it's my time. And how far does it travel? Again, we're looking for, that's a big delta x. Whoa, that's a big x too. So we're looking for displacement. Okay, so let's see. This one's got a little bit more of a challenge to it. Okay, so we're looking for displacement, which means I need to know v bar and t. I've got t, but I don't have v bar. Okay, so let's move on to equation 2. Let's see. V bar, if I have v1 and v2, then I can figure out v bar, and then I'm good. I've got v1, but I don't have v2. Okay. Let's look at the third equation. Here I can find v2 if I know v1, a, and t, which I do. I know v1 is 0, a is 4, t is 12, so v2 equals 48 meters per second. So now that I know v2, I can plug that into equation number 2. Okay. V bar equals v1 plus v2 over 2. 0 plus 48 over 2 gives me 24 meters per second. Now that I know v bar and t, so now I can find displacement using equation 1. So that's v bar 24 equals delta x over t, and delta x equals 288. So, these are a little bit more challenging. This is a 3-step problem, and this is probably more difficult, I guess, I don't know, maybe not, than some of the math you've done in the past. But it just takes a little bit of practice and being methodical and going through the steps. If you don't know what to do, okay, start by labeling what you know and then looking at the equations. Okay, one more example. A car accelerates from 5 meters per second at a rate of -1 meter per second squared for 12 seconds. What's its displacement? Okay. Alright, so this is my V1 again. That's the velocity I'm starting at. Okay. At a rate of -1 meter per second squared. The units are the tip-off, that is my acceleration. Okay. This is better than my handwriting normally is now. And for 12 seconds, so seconds tells me that that's my t. And what is the displacement? So we're looking for delta x again. So let's solve the problem. So there's what we were given again, V1, A, and T. Okay, we're trying to figure out delta x, which means we want to use equation number 1. In order to use equation 1, we need to know V bar. We don't know V bar. So we look at equation 2. Equation 2 means we need to know V2, which we don't know, so that means we look at equation 3. So equation 3, V2 equals V1 plus AT, and we get V2 equals -7 meters per second. And we plug that into equation 2 with our initial velocity, and we get that our average velocity is -1 meters per second. And then we plug that into equation 1. So we're 3, 2, 1, 3, 2, 1. Okay. All right. And that is it. What I want you to do is do 2.4. Make sure you show work for this activity. Take your time. Hopefully there's answers. I usually put answers on there. If not, I will go over, or I'll post the answer key tomorrow. So take your time, do a good job, and I'll see you around.